So how do you automate metadata generation? You'll need two key ingredients, really. You need some set of topics to choose from, and you'll need some idea of relationships between those topics. And then you can essentially just say this content mentions that topic, so it must be about it. And you use weightings and stuff that we'll talk about. So the ideal answer here is some pre-existing set of topics and relations between them. Unfortunately, for our domain of software development, that answer already exists and is right under our nose already. Stack Overflow. So Stack Overflow is a popular Q&A site with over 10 million questions. I think it's up to 19 million questions. It's 10 million questions, 19 million users. And all the questions are tagged with tags concerning what they're actually about. And all those tags are maintained by the community and moderated by the community as well. So that means we've got that closed set of topics which map well to our domain. And the more interesting thing about them is that because you can ask multiple tags on a single question, tags occurring together on one question implies that those two things are being used together. So that co-occurrence of tags represents real-world usage by people in our domain, essentially our customers. And the weight of that co-occurrence is also the weight of the edge. And so we stick all of that into the graph. And I've just got a brief sort of example of that. So that's the tag graph database is there. And this is the top tags which are related to us. And already you can see that this is quite useful, that we've got specific things of programming languages and Neo4j and actual instances of things which are graph databases. And you've also got more abstract things like NoSQL and database. So you've got concepts as well as specific tools. And so you can tell already that there's a lot of network effects there that we can take advantage of to learn more about what's going on. And the next step, of course, we have this network of topics, is just to attach it to our content. And so to start with doing that, we just chose to take all of the copy from the book page because that was the best place to start. And also, it's already designed to be quite keyword rich so that people can discover stuff from relevant search. So to start with, you can extract all the tagged the words, just any words from that. And you can see we get a bit, oh yeah, sorry, I should mention this, Learning Neo4j is Rick Van Bruggen's book, a very good book. And you can see, just extracting words, we can get a bit of an idea of what's actually going on there. It's about Neo4j, it's about data, technology, but it's also about Bruggen, learning, theory, use, stuff that means nothing to us, stuff that has a specific meaning on Stack Overflow, but to us, it's just noise. But when you filter that down to just things which are Stack Overflow tags, you get a much clearer picture of what's going on. It's about Neo4j still, but it's about graph databases, it's about modeling, it's about case, it's about graphs. So that's a good start, but you can see we've still got a bit of noise there. For example, for loops. For loops are the most popular topic in Pack publishing, if you just go by this. And that reflects the fact that we're just counting words at this point. We now have no idea of what specifically this document is about. So how do you overcome that? How do you cut through that noise? Well, we use an algorithm called term frequency, inverse document frequency, and that essentially balances occurrences of the term against the commonness of that term across all of your documents. So if you have one word which appears in every document, like for example, then that's going to be weighted, that's going to have a very high, very low IDF score, and so that will balance out the high TF, term frequency, and it'll push it down. So what that does is it allows you to get a clearer picture of words which are specific to this document and add information about that document. So if we apply that to what we had before, then you can see we get a much clearer picture again of what's going on. Some of the words that were there before, but some of the weightings are different, and things which are more unique to that book start floating to the top. And if we step back at that point, we realized that even by just including products and all these Stack Overflow networks in, we've already built quite a complex picture of our market. And from that, we can start doing interesting things, for example, making a visualization. So this is one visualization I put together, which is the top 1,000 tags on Stack Overflow and how they relate to each other. I've stuck it in Cytoscape and I did some clustering algorithms. And you can see already that the actual communities that we can see in that network really do represent what's going on in the real world. We've got web development, we've got databases, we've got normal programming, we've got mobile development as well. Yeah, and we can see the key influences, like I've pointed out some there, the biggest topics, and you can see communities and clusters. And this already has a real life use cases already, because These Stack Overflow tags are attached to products, and products are attached to customers by purchases. So we can already say customer X exists over here, basically. And so we can segment our customer list and do relevant things based on that, new product alerts, and do more personalized marketing that way. But this picture obviously is idealized. In the real world, every graph like this is going to end up more like a hairball, with the clusters not so well defined. So how do you decide which of those tags are the key concepts? Because obviously for loops, that's a very big concept, but no one's really going to be looking for a book about for loops. So we need some context for that data there. And the way that we'll do that is by adding in an ontology. So for those of you who don't know, an ontology is basically just a formal way of relating entities and relationships between those entities. And it's easy to define in terms of the property graph model. So we just started with a small manual tagging exercise where we got some nodes out, and we have a class structure based on real types of thing that people do based on real ways in which our customers would look for their information. So we have classes like programming language, databases, and paradigms, and tasks, and things like that. And then we stick it into the graph. So for example, you've got Neo4j, which is a database, and it's written in Java, which is a programming language. And the most important point here is that the ontology nodes are attached to the Stack Overflow nodes. So we're essentially elevating those tags and saying these are topics that we're interested in. And that means that you can then use all those network effects from Stack Overflow to inform the ontology and grow it further. So you could get, show me all the applications and show me all the topic nodes, show me all the programming language nodes that those are connected to. So you get, for example, Python linked to pandas and Python linked to NumPy. And so if you have that list like that, then you can automatically say, well, all of these are clearly frameworks for this programming language. And so you can somewhat automate that process of growing the ontology. And that gives us key concepts and that context that we need. So what we've got so far, we've got most customer touch points, and we've got a reasonable view of topics and stuff like that. And this was useful. We could start doing stuff like segmentation, as I said before, and we could start doing outbound recommendation emails and more marketing stuff like that. But we still don't know much about how the actual content's being consumed. It's very well for us to say, oh, person X wants to learn topic Y, sell them book Z, and get rid of them, and that's where the relationship ends. But what would be much more useful to our customers and to really deliver that value, we need to understand how they're actually using that content, and then what they're getting use out of and what's more interesting about it. And in that way, it helps try and organize people's learning and helps try and reduce that pain of learning a new topic. And to do that, we need two more fundamental elements in this model. We need the actual parts of the books, so the chapters and sections, and we need actual usage data of people reading those sections. So book parts are stored, I should have pressed that earlier. Book parts are stored in EPUB. It's just EPUB data, which is just XML basically. And so we can just take all of that and parse out all of the chapters and sections and subsections and stick them in the graph. So that's another Neo4j book, Learning Cypher, and it's got 4 chapters and some sections in each of those chapters. And so we add all those into the graph, and then we add the Stack Overflow tags, attach those to the sections as we did before. And we think, great, now we've got exactly what the books are talking about down to the page level and what those concepts actually represent. So surely this will tell us exactly what's going on and solve all our problems. Well, this is Rick's book again, and we take all the actual Stack Overflow tags from the book and apply TF-IDF to them again. And as you can see, some of the same concepts that were there before, but now we have a lot more specifics in there. We have actual specific things which are being used and talked about in the book. And it looks pretty good, it gives us lots of specifics, and that helps us in some way. But surprisingly, this approach didn't actually carry over to all of our books that well. So another book, a really popular book we've done recently, is Python Machine Learning. And so this is the same process applies to that book, Python Machine Learning. So you've got a lot of really specific things there. And these are obviously things which are covered in the book. Perceptron, scikit-learn, Eigen, Flask, LDA. Clearly, we've got it right. I mean, the word lasagna makes no sense unless you're talking about Python machine learning, really. But there's something notably missing here. The word Python, 1/3 of the title, has disappeared. This book is clearly about Python. Why is Python not there? Python has a TF-IDF score of like 0.03 in this book, which is just It's below any cutoff you'd put in. So Python's not there, but we know that there's lots of Python-esque terms there. We've got Flask, we've got Lasagna, we've got Gamma, we've got scikit-learn, we've got all of those things. So how do you then, from that information, bring Python back into the fold and say, okay, we know this book's about these things, we know these things are related to Python, so this book's clearly about Python. How do you codify that? And for that, we've used another algorithm called spreading activation. And this is originally from, I believe, from cognitive psychology, and it was used to model how memory flows around the brain, that you have neurons which activate other neurons, that sort of thing. But it's also being used in information retrieval now, and it can be applied generally to any sort of neural network or associative network. So the basic algorithm is that you start off with the picture that we had before. We've got a piece of, in our case, a piece of content, and you've got some topics which are related to that content. So those have been activated, those topics have been activated. You then iterate over all of those topics which have been activated with that weight, and you add in all of the connections between those topics to other topics. In other words, you spread that weight down through the network. So in this case, it spreads down from those guys down to Python, and GPU there may get a smaller boost, but not as much. And then, so that weight spreads over, you've got a bit of a decay there, and you iterate over all the nodes, and you end up with a new higher score. And that will bring Python right back up, and we have a picture of exactly what the book's about. So the final piece of the puzzle for the data model is actual book consumption. And so this was easy to add in at this point because the subscription library just logs every page view in a relational database, and we just pull that into the graph. And I was very happy when I managed to produce this eventually, that this is someone interacting with a book over time. So that's the someone in the middle there, and all the sections and chapters around them there. And so the sections that they've read are directly attached to them, and the sections they haven't read aren't directly attached to them. And so you can see from that how this person is sort of feeling about this book.
How do you know?
Oh, sorry, wait for the microphone.
How do you know which sections have been read?
That's from the subscription library, where it's a library in our web domain that every time someone clicks on a new section or chapter, that gets logged into a database with the ID of that section, which is the same ID as we have in the graph database. So we just put all of those things in there. And all of the edges between the customer has things like when they started, if they've bookmarked that section, if they've marked it as complete, anything like that, and how many times they visited as well. So you can start to say things like, oh, this chapter takes people longer to complete than this other chapter, or no one seems to read the appendix whatsoever, useful things like that. It's powerful for marketing and for products. Because just one person viewing a book, that's useful. What about everybody viewing a book? So here's Rick's book once again, and the bulk profile of take all the people who've read that book and aggregate all of that up. So we've got the chapters going across the x-axis there, and what's on the y-axis is how much of a chapter they complete, and the other y-axis, which is the blue line, is how many views per section are present in that chapter. So how often do people tend to come back to that chapter? So you can see already that the introduction gets quite high usage, but then chapters 2, 3, and 4, people just sort of skip ahead and they try and get to the meat of the book, and that's where people spend most of their time. And then also the other tools related gets a lot of usage, but that visualizations one doesn't so much. So that's really useful for us. We can start looking at books at the chapter level and feed that back into product development and say, this is how books should be structured. But we can also go back down a level and talk about what about different subsections of customers. So if we compared the profile for an expert reader to that of a beginner, would they consume books differently? Would one of them skim chapters more than the other? And then what does that mean? Does that actually have anything actionable back for product development? And also you could go back up again to the series level and look at how do people interact with cookbooks generally, and say, like, well, no one does read the introduction whatsoever, there's no point having it there, there's no point duplicating installation instructions across an entire 3 sets of books. So that was very useful for us. So that is the model that we've developed so far. We've got all the content practically down to the page level. And an important point is because it's XML that the book's stored in, there's nothing stopping us going even further and getting, for example, code snippets in there, titles, indexes, all that sort of thing. And it's only the analytics stopping us doing that because we don't have facilities to say someone looked at a code snippet a dozen times. But if we did, we could use that. And we could bring the code snippet in as well and add context to that and say this is a snippet about setting up something, doing something with it, that sort of thing. So talk about some of the sort of basic applications we've done with that. Now I'm going to talk a bit more about the other applications with some of the big applications we've made from it. But first, a brief note on how we've gone and put this into production. So this is a simple production diagram where we have Neo4j sitting in AWS. Interestingly, it's an EC2 micro instance, so 1 gig of RAM, and that's serving the entire website. And we haven't noticed any performance detriments whatsoever, which I think is testament to Neo4j's power. And that sits behind a Rails API. And the Rails API is really just a thin wrapper around the server that essentially all the models for the different queries that we use are just stored as Cypher queries. And the API just then gets a request, looks at the Cypher query, executes that on Neo4j, and returns some representation back to be rendered on the front end. Obviously, in real life, things are a bit more complicated than that. But if you'd like to talk to me more about the actual stuff we're doing in production, that would be great. You can come grab me afterwards. Now, at the start of this talk, I said that I wasn't here to talk about recommendations. Well, ultimately, I lied there, because everything that we're doing is a recommendation. We've come a long way from a shaky VBA script to help people buy books at the cart. But ultimately, everything we do is some form of recommendation, either from a book to another book. I think I've put it in a graph. A book to another book, a user to a book, or a topic to a topic, all that sort of thing. Even classifications that we're doing are a form of recommendation. And yeah, so what sorts of recommendations have we been doing? Well, the two that I'm going to talk about are tech pages and customer profiles. So what's a tech page? Tech page, we found it's a way to classify all of our content, some book content, mostly non-book content, around the key topics in the ontology there. So that's the Python page. We've got featured things at the top, new and popular, and then more stuff down below, and there's books and stuff further down. So how does that actually get compiled? So a request comes in to the API asking for featured Python content, and that just executes a Cypher query, like I said, and that just returns the node IDs, which are completely coupled to our CMS. And yeah, because it's completely coupled to our CMS, we just use the graph as a representation of the data, and the actual rendering of the stuff just gets handed back a list of IDs, and that gets hydrated by the CMS in the front end. And so this was really powerful for us for several reasons. Firstly, it meant that as soon as a new article or blog was published, say, for example, an article, Python versus R for data analysis, as soon as that's published, or even put up on the website, not published yet, it's already classified as being about Python, R, data analysis, machine learning, that sort of thing, pandas, NumPy. And so it will automatically, pardon me, get boosted to the top of the topic page there. Sorry, gotta drink some water. So as soon as anything gets published, it gets pushed up to the top. And because we store all the customer touch points, people engaging with the blogs, if it gets a lot of views, don't know if you can make it out in this room, but we sort it by how relevant it is and when it was published, whether it's featured or not, and views this month. So how often that's viewed in a month. So if it gets popular and gets lots of views, it'll rise to the top and might come into the features page. And all this happens completely automatically. And yeah, that's an example of the sort of dynamic filtering that goes on there. If, say, an article from like 3 years ago becomes popular for some reason, that'll automatically get pushed up to the top. And that really has given us a great boost in engagement, and it's driven the discovery of our content quite a lot. So the other use case is customer profiles. So this idea of spreading activation, of having concepts that are directly activated and then other concepts which are indirectly activated, we can apply that to customers as well. So if you have, so Greg, for example, this is, say, my profile from when I started. I'm interested in Python, a bit of VBA, Sigma.js, Neo4j's up the top there, kind of small, and Excel is where I do the bulk of my work. So for every touch point you have with a customer, you then do that spreading activation again and add the weights onto those topics into this customer profile. And as time goes forward, so you have a time decay, that the profile will sort of push down things that happened more time ago. And so you get a dynamic view of what people are doing. And so in the 2 years I've worked at Pact, my profile has changed from something like this to something more like this, where it's all about Python. I've totally replaced Excel there. And VBA still features, unfortunately. So this is really useful because those relationships, because they're from the ontology, they have that context of what the thing's actually about. And so we could start doing things like, say, what am I going to learn next? What should I learn next? We could just chuck everything at the wall and show me more pandas books, but that's not as useful as preempting that learning needs. So what we can do is, say we have a user, Ted, who's got a similar profile, and you can see that he's VBA and Excel featuring in his life a little bit. Instead of Python, he's using R, and he's using RStudio, which is simple for doing data analysis and that sort of thing. So he's sort of equivalent to where I am now, but additionally, he's recently started working on Apache Spark. So because we have all of the context of what these things mean, we can say, okay, so Ted is clearly a data analyst, and he's working with graph databases, but now he's started looking at Apache Spark, so it'll then be useful to recommend that I start looking at Apache Spark. And there's more interesting projects going on as well. Come and grab me if you'd like to know more. So what does the future hold for us? There's many interesting possibilities for the future, and I think the model is pretty much complete by now, but it's just finding out more and more things that we can do with it. So the first one that we're really interested in implementing is graph-based search, because we have terms that people actually use and recognize terms. We can use that network to generate search stuff, and if we don't have a bit of content on it, we can use the network effects to crawl back and get stuff we do have. And also you can put the user stuff in there as well and get a personalized view. And modularized content is a bit more far-reaching, but the one that I'm more interested in, the idea that books don't necessarily have to be books. What if we found out that chapter 1 from this book, chapter 3 from this book, and chapter 5 from this third book, that actually makes up what you need to know, and that's actually a learning path there. What's to stop us tearing those books apart and forming a new book and creating a completely bespoke learning path? Because it could be dynamic based on what the user's interested in as well. And the other application we're looking at now is this idea of skill mapping, of essentially saying we have books, and mapping those books and topics onto careers and jobs and things that people are actually doing with them, and then putting people in a place and saying this, allowing people to track their career and track what's going on and evolve it as it goes along and link it up with other data and do peer comparison, that sort of thing. So that is the journey that we're on. And I think the key sort of points of this talk have been how thinking with graphs have been a truly natural way to think about all these problems. And it's really helped us to change how we think about our problems. And really that everything's a graph when you start thinking about it hard enough. And also, as Emil was saying earlier, it's the extensibility that was really key here. We've had essentially one data model, and we just kept plopping stuff on top of it and building a more and more complex picture of our market. And that was really only possible with Neo4j. And so it allows us to really, instead of focusing on the technical aspects of how do we make this thing work, we can focus on the important business problems that are going on. So that's me. Thank you very much.